the iron. We are now going to take a look at how electricity makes a closed iron work. The iron naturally has a plug into a wall socket somewhere, which is going to give us 230 volts AC that we need to drive this appliance. This AC on the live wire is taken straight to the switch. Now this is not a normal switch, this is a thermostat type of switch, and we'll explain a little bit later how this one operates. The switch, when it is switched on, and depending on how hot you want the iron, is going to send the very same live through the switch to the element, and it will start heating up the element when the current starts flowing. On the neutral side of the element, the circuit is routed straight to a fuse, and this then effectively gives a closed loop. Once again, this isn't a normal fuse, this is a thermal fuse. As you can see, there is a little T and a degree symbol. This fuse has been rated to actually blow when the iron gets too hot. We will take a look where this component is located a little later on. When the switch closes, the current is going to flow from your plug through the switch, through the heating element, through the fuse, and then back to the plug again. Most modern irons will also have a little lamp mounted in it somewhere, which indicates when the switch closes and that there's power on the iron. So as the switch closes, the light will light up, and when the switch opens again, the light will go off, indicating that the heating element is getting power on and off all the time, based on the position that you've selected on the thermal switch. So now you can see there are actually two circuits happening in our iron. The first one, indicating here is blue, shows that when the switch closes, the current is going to pass through the lamp and the lamp is going to light up. In the second part of the circuit, indicated in green, you can see the current is going to travel along the open circuit, and it's going to heat up the element and then come back through the fuse. So two things are happening. When the switch closes, the light's going to light up, and the heating element is going to get hot. Because this is a thermal switch, the current is now flowing through the thermal switch, and as the bimetal strips heat up because the current is flowing, it is going to start bending. At some point, the contacts open, and the switch will automatically switch itself off. So here, the bimetal strip has done its job and has opened the switch. And now, of course, no current is flowing, and because no current is flowing, the bimetal strip is not being heated up by any current, so it cools down. As it cools down, the contacts are going to close again. And this will carry on until such a time as you finish doing all your ironing. And you will turn the switch to the off position, and the iron will be switched off permanently. Now let's take a look at how to repair the iron. Each different type of iron will have its own way of opening up the housing. If you look at the back side of the iron, there might be a few screws located here. These must be removed. Behind this base plate, there will be further screws to remove. These ones hold the handle plastic in place. Remove these. Other screws will be secretly hidden away and will mostly be underneath the push knobs of the handle. Lift up the water inlet cover, if there is one, and there might be a screw located here. This you must remove. Stick a short, sharp, flat screwdriver at the bottom of the knob and lever the knob out of the handle. New screws will be located here. These you will have to remove. Once all the screws have been removed, the heating plate of the iron should separate from the handle, exposing the thermal switch, the heating element, and the thermal fuse. The light bulb might be located inside the base plate section. Be careful when removing all the plastic parts and pay attention to how they go back together, as the steam iron needs to have all its water parts put together properly to eliminate leaks. Now let's test the components. To test the plug-in lead, set the multimeter to continuity setting and test for the plug's live pin to live connector. You should have continuity. Now test the neutral pin to the neutral connector. You should also have continuity. Test from the earth pin to the earth connection on the iron. You should have continuity. Test the live all the way to the input inside the thermal switch. You should have continuity. Test the neutral all the way from the plug through the thermal fuse to the input side of the fuse. This is located at the output side of the heating element. You should have continuity. If there is no continuity on the neutral wire from the plug neutral pin to the element, then it's safe to assume that the thermal fuse has blown. Test for continuity through the switch. Input side to output side. Continuity should toggle between off and on as you turn the thermal switch shank. If no continuity happens, then either the switch is broken or the contact pins are dirty. Try cleaning the contacts with a small piece of sandpaper. If it doesn't work, then the switch needs to be replaced. Switch the multimeter to the lowest ohm setting and measure the resistance of the heating element. This should be between 30 and 50 ohms. If you measure an open circuit, then the element itself has blown and a new iron pad needs to be inserted. A quick test of an iron is to measure for 30 ohms at the live and neutral at the plug, while you rotate the switch on and off. This will indicate whether the iron is working or not. Electricity is dangerous. When working on any electrical appliance, remove the plug from the wall socket.